Thanks everyone for coming to the Data Availability and Appchains panel. Let's start off by having our participants just quickly introduce yourself and your company.
Okay, so I'm Ming Wu, and I'm the co-founder and CTO of Zero Gravity. And Zero Gravity is building the modular AI chain, and it also serves this data availability functionality. And we are trying to achieve extremely high scalability to support this area. And yeah, so that's a basic introduction. Yeah.
I'm Rushi, co-founder of Movement. We're bringing the Move VM to Ethereum.
Hi, Anurag, co-founder of Avail, previously co-founded Polygon. Avail is this scalable data availability layer that we build, which has data availability sampling integrated. And we also announced a couple of products on top of Avail DA, which is Avail Nexus and Fusion. Happy to be here. I'm also supposed to rep Eigen today.
Okay, filling in for two projects then. And I'm Julia from Caladan. We're a Singapore-based market maker and trading firm. Let's start off with a fun icebreaker. So if you were to describe the crypto market right now as a food, what food would it be?
So I think the current crypto market is certainly the bullish market, and I see a lot of this increasing of this capital to this area in this industry actually triggers a lot of new narratives and innovations, and also the technology thing. And so I see a lot of new projects that's working on solving the different problems on this area to push the extreme of especially the trade-off between the scalability and the security. And also it triggers a lot of opportunities for combination of the Web 2 area technology with the Web 3 technology, like the AI intersect with blockchain. And so I fully I'm very excited about this new trend, and I think from tech-wise, I'm really happy to solve a lot of challenges to move this technology to be a more advanced stage. Yeah.
I said pomegranate because there's so many different pieces. There's like 300 different companies all trying to do something similar in some shape or form. But yeah, I think obviously it's a hot market and things are being distilled down. And we'll spend the next few months kind of distilling what stays here for the long run versus what's like a short-term thing. But pomegranate would be my short answer.
So this is, to me actually crypto seems like either like this big fat Indian wedding, like where you have food from all over the place, or like when you keep traveling throughout the year, right? Like so, a couple of weeks ago I was in London, then I was in Korea, and then today I'm in Hong Kong. Next week I'm in Dubai, and so it's like going to each of these places and seeing like eating new food every day. Like so, if you go to Korea, like you eat tteokbokki and very spicy ramen, for example, and so on. And so I think crypto is basically this place where there's a lot of different sort of foods, and each one vies to be the best. If each ecosystem is trying to say that, like this food is the best, for example, right? Like so, I mean, but if you kind of think of it, right, like all food serves one purpose, to solve hunger. So, I mean, and so I think the crypto landscape is a little bit of that, like different flavors, different spice levels, different tastes, but ultimately all of them for one grand purpose. That's how I like to think about it.
Okay, great. So to start off, can you just quickly summarize the importance of data availability, why it's an important problem to solve?
Yeah, so I think data availability is important for the needs of the off-chain verifications. It provides some security mechanism for the light client to verify their data and execution. Because it is very important in the security, so it has to employ some decentralized mechanism to achieve that. So that also means that it is makes more sense that it must be a shared system, a shared platform for with respect to the economic consideration. And so in that case, I think the scalability will become a very important problem to solve because it has to support a bunch of different layer 2s and also the Appchains, such kind of stuff. That will have a large volume of aggregated data throughput to the requirement for the system. Yeah, that's it.
I mean, I'm not building DA, so they're probably better suited for this. But from execution layer, like the way we look at it is, if you're doing a high throughput parallelization, which is one of the hotter topics today, you need a DA layer that can scale. It doesn't matter if you have 100 throughput, if like 100K TPS or whatever TPS. On execution layer, if DA is a bottleneck, that's what Ethereum is right now. So parallelization doesn't even work on traditional mainnet Ethereum. That's why you need alternative DA layers that can provide high throughput and lower gas fees. So if we can get down to like sub 5 cents, 4 cents, and then put a high performance VM, you truly have the perfect execution layer. But I'll let both of them talk more on DA.
Yeah, so see, data availability is nothing, it's not like new to blockchains. Data availability has always been there. Like every blockchain has data availability by default. I think the major things that, like why you hear of data availability is, of course, one is token number go up. That is number one. The second thing is basically because we have now kind of, like separated data availability into separate layers. And so what happens is that you need to optimize, and what we've optimized in, for example, something like Avail DA is that the ability to verify data availability as well as scale data availability independently. That's the main innovation, in the sense that we are able to now verify data availability very efficiently via light clients through data availability sampling. And so that is an important property when you're kind of trying to separate out execution from the data availability aspect, because if you have both intertwined, it's very difficult to scale both at the same time. So why this has become more known and more discussed right now is we're just separating out these layers, making each layer scalable, and also allowing for easy verifiability. And this last, easy verifiability, is important from an app chain perspective, because now, if you kind of think of it, right, there is this bunch of rollups or app rollups that get enabled, and they also need to talk to each other, not be siloed. And so these light clients enabled by data availability sampling really enable composability, right? Like it's easy to talk to these siloed app rollups as I speak, right? Like, so I think that's the gist of it.
Yeah, so playing off of that a little bit, right? In the context of a modular blockchain, how is on-chain data availability different from, when we talk about monolithic blockchains?
Oh, so I think from the modular perspective, I think it's mainly about the engineering experiences, engineering excellence. So basically, because this the DA problem is itself is very complex. So if we consider these things in a monolithic blockchain, that could make this system very hard to build. And but taking this modular way, and we can separate these different components with elegant interfaces, so that the developers for the different purpose, they can focus on their tasks more concentrated, in a more concentrated way. So in that case, for the modular DA system, they can the developers can design very very complex mechanism to handle different user requirements, because there's a lot of trade-offs between the security and cost and performance. So this actually, I think, could lead to better solution for this DA area, I think, yeah.
Yeah, I think the downside is often you're running a different consensus mechanism. So if you're ETH2, typically you're settling to Ethereum and you have the DA inheriting from Ethereum itself. Using alternative DAs, many argue that you have another consensus mechanism which creates security vulnerabilities. Most people are kind of combating that with what Avail and Zero Gravity are doing to try and minimize that risk. But adding another element to the modular stack introduces more complexities, which is probably the downside. But the benefit outweighs it severely when you have lower transaction fees, higher throughput. So it's a trade-off on both sides.
Yeah, I mean, on-chain data availability can mean a lot of things. So, I mean, let me try to kind of clarify. So, if you're talking about rollups, Ethereum rollups using Ethereum for on-chain data availability, or Ethereum smart contracts using on-chain data availability, so that's separate thing. I think the question is more towards if you use different trust zones or security zones for execution and data availability. So, for example, there's this, let's say, a Validium construction which uses Avail for data availability, and let's say Ethereum for proof verification, for example. So there you have this concept of on-chain and off-chain, but typically execution is done off-chain. So I'm assuming that's the question. In general, of course, there are certain different trust assumptions. You do data availability on a separate blockchain with different consensus, but there are ways and means to kind of provide verifiability of consensus on Ethereum. We built this VectorX bridge, which is a ZK consensus verifier for our consensus, which is Grandpa. And so that we use for verifiability on Ethereum. But in general, like the underlying thing is, if you want to scale massively through rollups, like you have to ensure high data availability throughput on the base layer. And the base layer has to make those changes to create more data availability throughput. And so Ethereum is doing that using the dank sharding roadmap. But I think that's going to take a little time, and that's why you have the demand for solutions like Avail DA, for example, that fit in the market need for more and more rollups.
Great. So what are some of the key challenges that your projects are looking to solve, right? For new projects that are building on top of and leveraging your solutions, what are the battles that you've already fought for them?
I think the key challenge is what we are talking for is for the scalability, because I think currently a lot of solution is based on the consensus-based protocol. That because I think the key thing is that we want to separate the concept of data storage and data publishing. So I remember there is a debate in the Ethereum Foundation that they said that what is data availability is. It has to be the data publishing thing, right? So, but I think it's not that precise, because even you only think about the data publishing, you also need to talk about where this data should be published too, and so that's the storage problem. And so in that sense, we think so our methodology is that we need to start from a scalable storage solution at the beginning, and then connecting with a consensus protocol that's mainly in charge of the data publishing property. So in this case, we can make the system much more scalable than current pure consensus-based protocol. So in our way, actually, for the data transfer, for the data storage path, and that will introduce a lot of large volume of data transfer. So in that part, we need to use the pure horizontal scalable way to manage that. But for the data publishing side, we have to use this consensus protocol to bring some security for this DA property. So in that sense, we leverage the DA sampling, which only requires a tiny amount of data that need to be get into this consensus protocol to do this synchronization. So actually, we minimize this broadcast overhead in this way. So that's why we can achieve this scalability stuff. Yeah.
I think we're focused on execution layers. So right now, single-threaded machines don't really scale. You can Arbitrum, ZK Sync. When there's high network activity, most of the chains clock around 100, 150 TPS. By introducing multiple threaded processing, we're bringing the parallelization aspect, but most importantly, we're focusing on security. Every year, there's $4.5 billion lost in smart contract hacks. The thesis behind the move from the Libra project was to stop a lot of the attacks based on formal verification. So if you can stop reassociated attacks and overflows at runtime, prevent them from running, and you can prevent a lot of the on-chain issues we're seeing with exploiters and hacker attacks. So I think we're uniquely focused on both the speed angle and the security angle, while many are just focusing on speed, which is largely over-indexed on.
Yeah, I think we are at that stage of the, especially on from the roll-up centric ecosystem, that there's this bunch of roll-ups that are coming up every day almost. It's becoming so easy for players to spin up chains, right? Like, so if you look at like Base from Coinbase, right? Like, I mean, they didn't go through the whole build a chain sort of a stage. They just went to the go to GTM stage. And so that's like a new primitive that a lot of builders are still just now discovering, that they can like spin up a chain pretty fast. Right? Like they can take a OP stack or a ZK sync or a Polygon CDK or an Arbitrum Orbit, for example, right? Like or a Starkware Mazara, and then they can just run with it. They can like take a alternative roll-up stack, right? Sovereign Labs, Stacker Labs, all of these are still maturing. Like Movement is coming up with some their version soon, for example, right? Like, and so once all of these mature, like you're going to see like these thousands of roll-ups popping up. Like specifically, I think there's going to be like thousands and tens of thousands of these app roll-ups. And so today, when we are talking to developers, what they're asking us is, can we kind of create constructions so that we can give our users inexpensive transactions? So if you look at something like Base, fees were pretty low. Of course, congestion happened, and so we have to do more scaling, for example. But essentially, we are also answering questions like, okay, if I spin up a new chain, where do our users come from? How can we lower the friction of users on another chain coming to our chain? Do they have to bridge through Ethereum or no? How can we bring more liquidity from other chains to our new chain, for example? So there's a lot of these problems that are still, popping up in developers' mind. But I think rollups are this whole superpower that to developers, that they can spin up a chain almost, like overnight, in that sense. And this is only going to accelerate with the maturing of more modern stacks.
Great. So it sounds like you're solving a lot of important problems around data storage, speed to market, and of course throughput. So final question to close. Can you describe how your data availability protocol or your project is different from others? So it's time to show a little bit. And also, what's on your roadmap for this year?
Yeah, so I think first that we are the only one that have a built-in decentralized storage in this DA system. And another thing is that we are targeting much higher scalability compared to what they can achieve with the existing system. And the third is that we also provide some programmability DA support that we are trying to interact with some external, the smart contract on the external blockchain to allow them to programming the smart contract to offload their state to our DA layer and get back at some later time asynchronously. And this also enables, it will also enable this state migration from one layer 2 to a different layer 2. So, fourthly, I think we are also focusing on, mainly focusing on AI scenario that have some special difference compared to the existing layer 2 stuff, because AI scenario, it may have a more volume of data requirement, and also they have the different data types, more variants, and also in the AI scenario, I think it's more important that we will bring some some value to the data and the model providers. So not that's a kind of a different thing, because for the layer 2 scenario, the DA data itself is not that valuable. I mean, we do not need to reward this data provider because it has been generated by the existing system. But for AI, for example, the model and the data has its own value. When you compute some result based on this data, and you have to give some corresponding credit to this data providers. So that's why we want to provide some model staking mechanisms in our system to make this data engineering area of AI stuff or in a more good way. So yeah, so I think this is a major difference of our system with others.
Yeah, I think obviously we're not focused on DA. We're focused on fixing execution layer. So the EVM is pretty slow today. It doesn't really scale to broader audiences, even though it has original network effects. So I think where we differentiate is providing an alternative execution layer that is pioneered by Facebook, has EVM compatibility so we can support legacy code, but also can support new styles of code that are parallel processing, higher performance, and also stops a lot of security issues in crypto. So we mark ourselves as the fastest and most secure layer 2 on Ethereum.
Yeah. So I think, see, we are at this point in the industry evolution cycle that like rollups have been around for 2-3 years. I think rollups are even now very underrated on like what role they play in the ecosystem. So, before rollups, what happened was it was extremely expensive to spin up new chains. So when you had to spin up a chain, you had to recruit a validator set, you had to create a token, you have to make the token valuable, so there's a lot of things of doing to spin up a new chain. Like rollups came and kind of changed that. Like it's now very easy to spin up these chains because you have these rollups share the security of the base layer. And so, like if I were to say, what we are really doing at Avail is we are basically enabling this rollup future for blockchains. Right? Like we sincerely believe that rollups are going to be the futures of how blockchains are going to live, and we are kind of building infra that provides support to the growth of this of the rollup centric future. We are really trying to build infra that coordinates the entire rollup centric future, and so this is infrastructure for rollup scalability via Avail DA, but also infrastructure for rollup interoperability via Avail Nexus, for example, and so on, right? I know we are on a data availability panel, but data availability is just one part of the entire puzzle, right? So there's this entire ecosystem around it. There's the execution stuff, there's data availability stuff, there's interoperability stuff, there's economic security stuff. We don't do everything. We basically don't focus on execution, for example, because those teams are the ones that are specializing in execution. And we think that there will be like this, like similar to how in Web 2, you have different sort of programming languages and everyone chooses their programming language. Here, there is not only a programming language, but there's also an execution model, a state model combined into one. And so we'll have these execution players do a lot of experiments, and that is what is required, right? Like you need to lower the cost of experimentation of doing, let's say, a Move VM or a Wasm VM or a Cairo VM, for example. And so I think that's the experimentation that we want to do. And what Avail really does is enable the entire ecosystem to scale or coordinate the entire ecosystem, from data availability, but also from, making all of this interoperable, so that the user at the end doesn't have to contend with like 1,000 chains, so yeah, that's where we stand.
Fantastic. Thank you so much to our panelists, Anurag from Avail, Rushi from Movement Labs, and Ming from Zero Gravity. Thank you.
Thank you.